There's a situation I run into quite often with cordless drills that have been around for a few years. When the tool is new, everything works perfectly. The battery charges quickly, the drill feels strong, and you can work for quite a while before the battery even starts to slow down. But after some time, one day you grab the drill, plug the battery into the charger, and something just doesn't seem right. Sometimes the charging light blinks a few times and then turns off. Other times the light stays on like everything is normal, but after waiting for a long time the battery still doesn't seem to charge. In some cases, you charge the battery, attach it to the drill, and the drill runs for only a few seconds before losing power, almost like it suddenly ran out of breath. And occasionally, you plug the battery into the charger and nothing happens at all, which makes many people assume the battery is completely dead. Because of that, the usual solution is to take it to a repair shop, replace the battery cells, or simply buy a new battery pack. But anyone who has bought a replacement drill battery knows they're not exactly cheap, sometimes costing nearly half the price of the drill itself. The interesting thing is that in many cases, the cause is not as serious as it seems. After a few years of use, the battery voltage may drop too low, causing the charger to think the battery is defective and refuse to charge it. In other cases, the contact terminals become dirty or oxidized, preventing a proper electrical connection. Sometimes one cell inside the battery pack becomes weaker than the others, and a protection circuit blocks the charging process. These problems often come with other symptoms as well, such as the battery charging very quickly but draining just as fast, the drill feeling weak even right after charging, or the charger blinking continuously. The good news is that many of these issues are actually quite simple to check and fix, sometimes taking only a few minutes and costing almost nothing. So if you're stuck in a similar situation, don't worry. This small problem actually has a simple solution, and I'm about to show you how. The first step is to remove the outer plastic casing of the battery pack, so we can check inside and see if there are any hidden causes preventing it from charging. Once the battery casing is open, one of the first and easiest things to notice is dust buildup inside the pack or slight oxidation or rust on the metal contact points. These issues can weaken the electrical connection, which may cause the battery to charge poorly or not charge at all. That's why cleaning the contacts and internal components is an important step. When it comes to cleaning electronic components, 90% alcohol is one of the most useful and commonly used solutions. Because it evaporates quickly, it can remove dust, grease, and light residue from electronic parts without leaving much residue behind once it dries. When used on metal contacts, component leads, or circuit boards, alcohol can also help remove light oxidation, which improves electrical contact. Another advantage is that once the alcohol fully evaporates, it does not conduct electricity, making it relatively safe for cleaning small electronic parts when used properly. In most cases, you only need to apply a small amount of alcohol to a cotton swab, soft cloth, or cleaning stick, then gently wipe the contact points or dirty areas. Thanks to these properties, alcohol is often used for cleaning circuit boards, battery contacts, switches, and other small electronic components. Next, I have an old phone charger that still works but is no longer in use. Instead of leaving it in a drawer, I'll repurpose it into a simple tool to help wake up the battery cells inside the drill battery pack when their voltage has dropped too low. The key is choosing a charger with reasonable specifications, typically 5V with about 1-2A. This level of voltage and current is gentle and stable, allowing the battery voltage to rise gradually without stressing or overheating the cells during recovery. Once the voltage reaches a normal level, the original drill charger can recognize the battery and continue charging as usual. These are two small alligator clips, a very common tool when working with electrical or electronic equipment. With their serrated jaws and spring-loaded design, they can grip wires or metal contact points securely, making temporary electrical connections quick and convenient. Because of their compact size, they're often used for power testing, circuit checks, or quickly connecting power to a device. Please connect everything the way I show to avoid mixing up the terminals. Even a small mistake could cause a short circuit, which may heat up the wires or potentially damage the battery or charger. So before applying power, it's a good idea to double check that the clips are connected to the correct terminals and secured properly. During this process, check the battery about every 15 seconds to make sure everything remains stable. Continue doing this until the drill battery gradually recovers and returns to a normal voltage level. All right, it looks like the battery has recovered quite well this time. Now I'll reassemble the battery pack and close the casing, and after that we can put it back to use like normal. As soon as I attach the drill battery pack, the indicator light on the dedicated charger changed color, showing that the battery has started charging. However, to know whether the battery is fully stable, we'll need to let it charge completely and test it afterward before making a final conclusion. And just like that, the drill battery is working again. Sometimes problems that seem serious actually come from very small issues, and with a bit of checking, they can often be fixed right at home. This not only helps save repair costs, but also helps us better understand the tools we use every day. I hope the simple method in this video is helpful to you, and who knows, somewhere in your workshop there might be another battery waiting to be brought back to life.